Hi everyone, sorry for complication. Thanks for being here. I'm Vojtech Trcka, and today we talk about container security. Why is the most of Docker's images are fat, are full of holes and total mess. The goal is simple: choose better base image and ship only what your app really needs. Okay. Who am I? I am a product security engineer. I break stuff for a living. I have 20 plus years experience with Linux, and yeah, it is probably right. I use Arch, by the way. In my free time, I train on the Hack the Box and try Hack Me, which is a healthy way to use criminal skills. And outside work, it is 3D printing, home labs, do it yourself, like this 3D printed alert button in our office. It does nothing useful yet. It just makes our team feel powerful in the incident time. This tool came from the real work. I build these images, I scan them, and also I hack them. So let's start easy. Okay. Let's start easy. You need Python, right? So what do? You start typing from Python 3.12, for example, and result is 1.6 gigs for your of image for your 5 max application and lot of vulnerabilities. Why? Because you don't pull just the Python. The rest is operating system, tools, packages you never want. It's like coffee. Okay? You are ordering coffee, but you get a coffee with barista diploma, whole kitchen, and the goat, but you didn't ask for the goat, right? But you have to patch the goat. And Python is not special there. Default, no, Java, Go, whatever. It's same thing. So there is a spectrum of Docker containers, default. These are real numbers. I scanned these images last week by IV 69.4. I'm just kidding, but I see you. Half of you start getting nervous, right? No? Okay. Node 24, 1.6 gigs, 33 criticals. Worst one. Python 3.12, 5.6 gigs, 7 critical. PHP with Apache, 724 max, 1 critical. Even Debian theme is quite lower. It is about 179 max and 28 highs, still relatively high. And the official Microsoft.NET image. Fun fact, Debian Slim inside, 350 megabytes and 16 highs. So when Evan says, but that is the official image, official doesn't mean safe. You haven't written any line of code, but the mess is already yours. Random packages, hidden bugs, You didn't choose them, but you own them. And we developed a very smart process. Scan, panic, ticket storm, debate about severity. After that, Marcus accepted risks and repeat next sprint, month, quarter, That is a compliance post play. It's not security, it's audit theater, but we are run for scanners. That's one. For scanners, there's just 4 options for the same channels. And this one is pretty nice, right? Yeah, this is still critical. Send you someone 3 weeks after initial alert. Same person who marked this issue as accepted risk. Looks familiar? Yeah, exactly. The usual approach is patch everything, track everything, and more scanners. What is the result? More bugs, more spreadsheets sorted by maybe critical, more dashboards, but still no fix. And then someone put into the Docker file apt install curl vim netcat and some others, just in case. That's not hardening, that is a gift basket for the Nope. Yes. And here's a big idea. Do not patch what shouldn't be there. Just remove it. No leap XML2 inside equal less risk. No shell inside, no shell to abuse. Security is not about aiding more, it is about having less. Fewer packages, small attack surface, fewer 3 AM wake-up calls, and it is just a least privilege for your file system. Yeah. And there is a spectrum of base images. On one end is Ubuntu and full Debian. There is shell, package manager, tools, and a lot of extra risk. Fine for development, but really bad for production. Then Debian Slim. Still there is shell. It's less, smaller, fewer packages. Then Alpine. Tiny image. There is still shell, but it is a big win for many apps, but there is one thing which is quite different, and Alpine use muscle instead of GHC, which sometimes cause to the weird surprises during you try to build your app. And then distros. That's my favorite. Just runtime. No extra, no shell, no package manager, no easy abuse. And finally Scratch. 0. Nothing. It's really good for static Go binaries. I heard many times, we have always used Debian. Sorry, but that's not a security argument. But we need SDK for the build hour up, and you have right. But only build during build time. Nobody runs .NET build in the production. I hope. One stage, stage 1, the builder. Use the big SDK image. Build your app. Stage 2, the runner. Copy only finished app into the tiny image. Distroless, Slim, Scratch, Surpic. Your build image can be 2 gigs. Who cares? Nobody. Yeah. Why? Because never leaves leaves the build server. What matters is what's go to the production. Think of it like cooking. You need whole kitchen for preparing food, but you don't send kitchen to the customer. Just the plate. And there is example for Python, JDK, and Go. You can use Scratch. So, 5 easy wins and plus extra. 1. Don't run a suite. Use user 1001 on or different number. If your app needs root, that's a really real problem. Second, make file system read-only. Use read-only flag. It's harder for attacker drop tools and files. 3. Drop Linux capabilities. Start with cap drop all and add back only what you need. The most app really need nothing. 4. Enable no new privilege. Yeah, stops easy privilege escalation like suite. Yeah. Mount only what you need. And never mount Docker socket into a container. Small changes, big difference. And I want to give a quick shout out Wolfie and Chingar. Someone know about? Yeah? Okay. Wolfie is a container first Linux. APK like use APK like fine, but there is glibc instead of muscle. Everything is built from source, scan it constantly, and may stay clean. So goal is 0 CVE or need to be 0 CVE, and also it is open source. Chinguard turns that into the ready-made images for Python, .NET, Java, and many others. Also, minimal, signed, and verified. So minimal is too hard. Excuse doesn't really work anymore. Enough theory, and what happens? Let's see what happens when attacker get in. And, sorry for that.
Shop from there. There's a problem. A small problem. Yeah. Yeah. Okay, but stream is checking. Sorry. Sorry, a little bit complication. Yeah, all right. So we have there two same applications. One is running Debian. Second one is run the distroless string art, whatever. And we can try what happened. There are two vulnerabilities. First is command injection, and second upload files. So we can try to bypass what happened. So we can start with command injection, right? So basically we have their ping somewhere or something. We have their get their semicolon, and some command should be run. So how you can see there is a root. Okay, we are root in this container. So what we can try on the distros should be same or different. Okay, ping is running. Okay. And who am I? Nothing. Okay, we can try to where I am. It's not working, right? So we can back to the first one, malicious, which is running on the full Debian. So, for example, this should be working, right? And we have the risk of shadow. Great. Second thing, but we need more. We need a web shell or some session on the meta pattern, right? So we can try to start with Punisher. Basically, there is with only text, PNG, and the JPEG. So we can try to upload our web shell, but it's not working. But when we try to go a little bit bypassing, it's upload. Okay? And we can also, on the Debian one, we have the web shell. So we can try, who am I? Oh, sorry. Right demo. I'm root. Okay. And we can try on these tools. There shouldn't be any privilege of that yet. Any tools. So we know the bypass is already there. So upload the shell and nothing. Great work. But that is also, it's not enough. We have probably better solution for that. Do something know what should be it. For example, meta pattern session should be fine, right? So we can try to create a payload and start press console. Try to upload our new shell. We tried, I just prepared the hardware. So we are running interpreter, TCP payload. So set payload payload. And without mouse, absolutely unused. Set the port. Set our IP. And we can. I would like to show you how this is working. So there is a malicious one. So we can try to upload our metadata session payload and run it. And probably we have to get shell. It's a problem. So we can figure out what is running there. When I boot still, I can get, for example, APC shadow as before. Okay, we can do this session and try on the different way. So on the list was out. So upload the session, started and live. Run the payload, and we get metadata, right? But that is quite useless, because we are trying to figure out what we are, which user we are. There is no out. We try to get shell. There is error. We are trying to get what processes are running on the machine. We get 0. We can also try something harder. For example, upload. What we can is where we are. That's all probably. We can upload because where we are. And also, there, so sh and execute. But it also is unless. So in the end, I would like to compare how is the difference. So there is a Ru1 distro-less 48 megabytes, and full Debian have 520 megabytes. And also, if we are scanning these two, there is a big difference because this one is Debian, which has 1069 vulnerabilities, 1 critical, 88 highs, and 129 medians. And distro-less is just 0. Okay, I try to jump on presentation.
So, after getting, you really need shell, writables, file system, network access, tools, package manager. The wrap app gives you all 6. Yeah, it's like Airbnb, walk in, use Wi-Fi, open the fridge, and blew up. It's 06. Yeah, you are standing in the potato with the most unless session ever. This is when the attacker or hacker gives up and looks for an easier target. That's mean you did it right. We have time or we have everything. So, how to start it? So, security alone doesn't get budget mostly. Faster does. Small image is built faster, pull faster, deploy faster. Less storage, less cost, and what is the most important, fewer bugs is equal to fewer alerts. Fewer alerts is equal to fewer pre-AM calls, and fewer pre-AM calls is equal to fewer engineers updating their LinkedIn in the Monday morning, right? Safer is also faster, cheaper, and simpler. You don't lose anything. Just remove what you really need. What you don't really need. So, sorry. That was this one, yeah? Sorry, I forgot it. Okay, never mind. So recapitulation. Part harder. Lock down the runtime. Better, fewer bugs, smaller target. Faster build, faster deploys. Stronger, tough against real attacks, not just on the paper. Make your container harder, better, stronger. When your attacker gets session and said, yeah, this is now unless it is time where you win one. Thank you. I'm Vojtech. Thank you. came to me and talk about containers or share your worst Dockerfile horror stories. Thank you. Questions? Yeah.
If this new feature of Docker hardened images can help somehow.
What?
If this feature, like a new feature from January this year of Docker hardened image, can help somehow.
This is basically, I think, it is the same.
Okay.
Yeah, this tool is developed by Google, but also there are more ways how to build it, and this is just a runtime. Right? Yeah.
You mentioned there is like a faster build time for the images.
Yeah.
You still need the pigeon to build the image from which are copying the files to the visualized image.
Yeah, it is mean like from a SRE perspective, right? You as engineer make a build, SRE is deployed, and time to deploy is much faster, right? You build whole container, just deploy somewhere. Okay? Thank you.
So let's say hypothetically that you need to use Ubuntu.
Mm-hmm. Why?
How would you? Let's say hypothetically that you have no saying and your paycheck is not big enough to take the decision. So how would you slim the image? I mean, how would you reduce the size?
I think the solution is in the presentation, so that is multi-stage build, right?
Okay, so multi-build where you kind of like
yes, you have builder which is built application itself, and you just copy this application to the runner, which is basically runtime, nothing else.
Okay.
Yeah, it's okay.
Kind of, yeah.
Kind of okay. So, thank you very much.